Hello, dear students. So far, we have discussed about circular motion, centripetal force, centrifugal force. On the basis of centripetal force, centrifugal force, we are going to discuss about the mechanism of banking of road. When the vehicle want to take turn over a circular turn or turntable, then we should have to discuss about the banking of road. It is the mechanism where the outer edge of the road is raised by certain amount over the inner edge, and this mechanism is referred as banking of road. To see more about banking of road, let's see the slides over here. This is online lecture by Anita Patil, as you know. The rising of outer edge of road over inner edge is nothing but banking of road. The figure shows this is the inner surface of the road and this is outer surface of the road. This is the inclined line showing inner surface and this is for outer surface. The angle developed between these both lines is nothing but the angle of banking denoted by theta. Let's see which kind of forces acts on a vehicle when it willing to take turn over a circular turn. This is the weight mg of a vehicle directed toward downward, and this is nothing but the direction of normal reaction because the vehicle is inclined on a line or surface of road. The direction of normal reaction is this. The normal reaction is vector and its component, vertical component is n cos theta and horizontal component is n sin theta. These are the forces working on the vehicle. From this figure, we can say that the weight mg of vehicle is balanced by vertical component of normal reaction, that is n cos theta. So we can write n cos theta is equals to mg. And this is nothing but the central second force. If we consider this is the circular part of vehicle, here there must be nothing but center of the circle, and this force is nothing but towards the center of circle, and the force which is seeking towards the center of circle is nothing but centripetal force. When the vehicle want to take turn along a circular path, it must have some amount of centripetal force, necessary centripetal force, so that the vehicle can take turn along circular path. So that amount of necessary centripetal force is provided by the horizontal component of normal reaction, that is n sine theta. So we can write n sine theta is equals to the magnitude of centripetal force is equals to mv square by r. So in next slide, these forces are balanced in such a way that n cos theta is equals to mg, that is equation number 1, and n sine theta is equals to mv square by r, that is equation number 2. Let's divide equation 2 by 1. We get tan theta is equals to v square by rg. If we find theta is equals to tan inverse of v square by rg, then we are able to find out the angle it should needed to bank the road and to take safe turn of vehicle. This is the case when frictional force is not there. When there is a frictional force exists, in case of coefficient of frictional force, that is mu is not equals to 0, it means it must have certain kind of frictional forces over there, its magnitude over there. Then we can see the different forces in that case, and those are the frictional force. The direction of frictional force always opposes the motion, so the motion is going on like this, then this is the direction of frictional force. Frictional force is also vector quantity there. If we resolve it into its component, then one vertical component is f sine theta and horizontal component is f cos theta. The horizontal component is towards the center of the circle. Actually, it is the radial component of acceleration, that is A is equal to V square by R. So the necessary centripetal force provided by these kind of component. So F cos theta is equals to magnitude of centripetal force is equals to mv square by R. So f cos theta is equals to mv square by r. If r is radius, mg is weight, angle of banking is theta, n is resultant of normal reaction, f is resultant of frictional force, then let us resolve all the forces horizontally and vertically. As the vehicle has equilibrium in vertical direction, then we can say that n cos theta plus f sin theta is equals to mg. This is n cos theta plus f sin theta is equals to amount of uh, gravitational force, that is weight mg. If we refer for this case as equation number 1, then the next equation is f cos theta plus n sin theta is equals to mv square by r. As they both addition of these both the components, necessary amount of force is provided by them, so the addition of they is equals to mv square by r. Further, if mu is the coefficient of friction, then we know that the frictional force is equals to mu into n. Mu is nothing but the coefficient of friction and n is normal reaction. Frictional force is always the product of its coefficient and normal reaction. So by putting equation 3 in 1, it gives n cos theta is equals to mu n sin theta plus mg, which is equals to n cos theta minus mu sin theta. By connecting these both, taking common n is equals to mg. N is equals to taking this whole quantity into this side, mg divided by cos theta minus mu sin theta. Refer this equation as 4. Putting equation 3 and 4 into 2, it will give us mu into mg cos theta by cos theta minus mu sin theta plus mg sin theta divided by bracket cos of theta minus mu sin theta is equals to mv square by r. By simplifying this equation, we get tan theta is equals to v square minus mu rg divided by bracket rg plus mu into v square. If we find theta is equals to tan inverse of this quantity, we are able to find how much angle is required in between inner and outer edge of the road. By using that, we can get the mechanism of the banked road. If we want to find the speed of a vehicle on bank road, so we can rearrange this equation for the speed of vehicle, that is v square is equals to rg into bracket mu plus tan theta divided by 1 minus mu tan theta. V is equal to under root of this quantity will give us the exactly speed of a vehicle. So in this way, we are able to find the angle for banking and speed of a vehicle when vehicle want to take step turn along a curved road. This is all about banking of road. Next slide, in next video, we will see the more terms related to circular motion. Thank you.